Now, what we are going to do is to look at how productivity and production have an impact. So ultimately, we are interested in profit. We are definitely interested in return on capital employed on a project. Okay, as we go back, what is the influence of time and cost on this? From a schedule point of view, both get impacted. From a cost point of view also, both get impacted. Now, what does productivity and production do to time and cost? What does productivity influence? Time and cost. Productivity influences time and cost. What about production?
Cost.
Production influences cost or time? Time. Much more of time. So productivity influences time and cost. Production primarily influences time, because I can, if I'm slow, I can increase my resources on a project. I can increase my resources, and the increased resources will cause increased output.
Productivity will be less.
So productivity will be less, my production will go up, I will catch up with time, but I'm paying with cost.
Extra cost.
Okay, and this happens a lot on our projects, right? We have some delay on something, and then we increase the resources, increase the labor, bring in more equipment, get more output, but we don't necessarily measure what's happening to the productivity. We increase production. Okay, and when we go back, you can see, so then these inputs and outputs are there, and you've seen the various factors that go into the inputs and outputs. So if you look at this big picture, there is a importance on productivity and production on the final profit and return on capital employed, and we will come into a little more detail on this after the next topic which we take. Okay, and this is the topic which we are going to take up next, which is to understand how productivity and production are related to cost and time. Okay, so you can see that what we have here is basically, I would call it a graph or a matrix. I will just put it as a matrix, as a management matrix. You have 4 quadrants. Okay, quadrant, you can see the 4 quadrants, that is, there's 1, 2, 3, 4. At the middle, we have the planned productivity and planned production. So this is almost a graph. Okay, so this is not a 0, 0 origin. This is where my planned productivity is the x-axis, production is the y-axis. Okay, so this is my middle. As my actual productivity gets more than planned productivity, I will go in this direction. As my actual production gets more than planned production, I will go up here. So any activity you're doing, if you measure production and productivity, you can fall in either one of these quadrants or right in the boundary or in the middle. Okay, any questions on this representation? Okay, so we will take this a little more detail. So our objective is to take this illustration and see how we can use this representation to understand how productivity and production influences time and cost. So the illustration is simple. We have a project requirement of 1000 poles, okay, to be installed in 50 days. So you can see these are typical, lighting poles on a street. And so if we say that these have to be installed in 50 days, that's all I'm giving an initial requirement. So you need to install 20 poles a day, and that is the production. And based on data, we are saying that, look, a crew which we are mobilizing for this job can install up to 2 poles per day. That is, I'm taking it at crew level. Crew might be, might be 2 workers, 2 helpers, whatever it, we are just taking it abstract form, can do 2 poles per crew day. Also giving you a little more information. So if you take the total crew days required, okay, it's 500 crew days. That is total, so that is the total number of crew days required. So if I have 500 crew, it means 1 day. Okay, so depending on how much, so it depends on how many people I can mobilize. And my cost of labor is given there. It is 2,500 rupees per crew day, working out to 12.5 lakhs is my total cost for labor. Now, what we are going to do is we are going through different scenarios that can happen. So, now this is my plan. What you will see here is different scenarios A, B, C, D, E. Each scenario is independent. Okay, each scenario is independent. We are only going to discuss these scenarios. We give you a number of poles installed and number of crew that were used to install the number of poles. And what we are going to try to do is to see, based on the number of poles installed and number of crew used, we have the productivity, we have the production, right? We have the total days it will take. So this is the productivity and production calculation. Then here we have the target. What I've shown here in these three numbers are the target. That is 50 total days is the target. We need 500 crew days at 12.5 lakhs. That's target. That these numbers on top will remain the same. But here for scenario A, what is the total crew days that will actually take given the productivity? Okay, given the the total days, given the crew days and the labor cost. We are going to estimate this and we are going to see it with relation to the quadrants. Okay, so this is where we are going. We are going to take it scenario by scenario. So, taking scenario A. Okay, so number of poles installed in scenario A is 20 and it took 10 crew. This is, assume this is the first day of operation. You had 20 poles installed by 10 crew. What is your productivity? 2. Okay, your productivity gets to be 2 and your production will be 20. Okay, now if I take 2 and 20, it is exactly the planned. It's exactly, so I mean this is a bit of a hypothetical situation. It worked exactly as planned. So that is where my current point is. Okay, now the total days will obviously be the same. Okay, if I continue to work at this pace, I will finish on 50. I will need the 500 crew days. I will need 12.5 lakhs to finish. Scenario A, and that is exactly where the point occurs. Now, so you can see we have some formulae up there with required number of poles installed by number of crew gives you the productivity. Okay, total poles divided by production is total day, total poles by productivity is the crew days. If you need to use crew days into the labor cost gives you the total cost, labor cost. If we now go to scenario B, slightly different numbers. Now 10 crew installed 22 poles in that day. So this is independent scenario. Instead of scenario A, now we have scenario B. So my productivity is 2.2. My production is 22. So where would this be? Which quadrant would it be in?
First quadrant.
Quadrant 1. Okay, so I'll be in quadrant 1. Is this a good quadrant to be in?
Yes, sir.
Yeah. Okay, my production and productivity are better than what I had planned. Okay, so I would expect both my cost and time to be reduced. Okay, so if I go in for total days, instead of 50 days, I'm finishing it in 45.5 days. Okay, and instead of 500, it's reduced. And my corresponding labor cost is also less. Okay, now go to scenario C. Now I have 25 poles installed by 15 crew. Okay, productivity. Okay, so we go in, this is back to the quadrants, 1.67. Okay, production is of course 25. And where would this be, on which quadrant would it come? 1.67 is less than 2. So remember, this is 2, 1.67 and 25 is more than 20. So it comes into quadrant 2. Okay, so now I have, my production is good, my productivity is is less than what is planned. My production is more than what is planned, my productivity is less than what is planned. And because my production is good, I am able to finish it before my 50 days, but more crew days. I will need more effort, more crew day input goes in, and so my cost goes Okay, so do review this. Okay, you should be able to go into details, and there will be might be in the quiz and in the examples they will have more elaborate version, but this is the principle on which is based. We go to the next scenario, D. Now I've installed 15 poles and it's taken 10 crew. Okay, so you can see you know what's coming. Okay, so you have productivity of 1.5, which is less than what we had planned. We have production of 15, again less, quadrant 3, in which case that's quadrant 3, and the result is both cost and time are in the negative. Okay, that we are going to overrun cost and overrun time. Okay, so now we go to scenario E now. So here in E, what we have is now we had 15 poles but less crew. So if you compare the earlier scenario, we had 15 with 10, now we had 15 with 6. Okay, productivity is more. Production is still 15, productivity is more than 2, production is less than 20, which means it is quadrant 4. This is E. Now what is the implication on cost and time?
Time will be less.
Okay, time, remember production is
15, okay.
Production is less.
Time will be more.
Okay, so total days will be more. I'll have time overrun because my production, I'm just not getting the throughput. My productivity, my crew are very efficient, but I'm not getting the throughput I need. Okay, and we think that we are saving on labor cost, but because my duration has increased, my overhead cost might be there. So by no means do we actually finally save on project cost. So this is a dangerous scenario. Okay, I might be getting, so a lot of times in the past if people put very few crew, so there will be less crew interference, this, that, etc. Productivity might be high, but the production becoming low, and if there is no, you don't see this scenario often today because there's a huge kind of premium put on time, on schedule. So a lot of times today we see more of quadrant 2, but in several situations quadrant 4 is also possible, but by no means does the cost come out okay, although just the labor cost might be okay, seems okay. Okay, so we went through these scenarios, and to summarize, this is what it looks like. We have put all of these now. Are there any questions which you have or any comments? Yeah.
So actually, can we say that productivity is directly proportional to production?
It's not directly proportional. No? We just found that, right? We just, in this whole exercise, we found that. So if it is proportional, then I won't have 4 quadrants, right?
Yes, sir. That's why I was confused. These are not totally related to each other.
They are not related to each other. Correct. So as you can see, I can have high productivity, low production. I can have high production, low productivity. That is really the message, that you can't measure just productivity or production and control your cost and time. Actually, okay, let me put it the other way. Which one would you, if you wanted to control one item, which one would you try to control? Productivity. But you can see in quadrant 4,
Productivity is there, it's still production.
productivity is there, but still production is not. Okay, so ultimately you have to keep track of both. You can't just keep track, a lot of times. So which is easier to keep track of?
Productivity. Production.
Production is easier to keep track of. Okay, so we do tend to measure and kind of control and do production because it's easier to keep track of, but we miss productivity in the process. And so as a result, we miss
The productivity.
what is the time or cost? We are not able to control cost. Okay, so we have to, if we are looking at where should we focus, we should focus, not just ignore production, but also start focusing on productivity. And they are, you can see they are not correlated. They need not be correlated. Okay, if I keep my crew constant, increase my production, increase my output, yes, my production increases and my productivity, but a lot of times the crew is not constant. The denominator of input is also varying. Any other questions?